All right, so now we're going to turn to the derivatives of the complex logarithm, and the same thing is true. Namely, if we look at the principal branch of the complex logarithm, when we differentiate log, we get 1 over z, and this is provided the z is sort of properly in the part where the domain defined by the principal argument. So what I mean when I say that is we want to look at not necessarily all z's. We want to get rid of the portion in red. Right? That's where we have a discontinuity in the argument, and so what this does is it ensures that we have a nice open area where we can compute a derivative. Now you don't have to worry about the technical details, but you just need to know that this formula that we're going to use, at least as it's written, only holds, well, is only guaranteed to hold rather, when we are not plugging in points on the non-positive real axis. All right, but nevertheless, the green area is where it's okay, and it's okay at most points. And here the derivative exists, and it exists at all those points, so it exists at nearby points. So this is an analytic function. And so what we have is a product of analytic functions. And so to compute the derivative of that product, we use the product rule. So that's the derivative of our first guy times the second plus our first times the derivative of the second. All right. Derivative of z is 1, it goes away. The derivative of log z is 1 over z, and so we get log z plus 1. Fantastic. Now let's look at another function here. What we're going to do is we're going to look at log z plus 1. And this makes sense provided z plus 1 does not have a negative or a non-positive real part. And so that will make sense, I think, for all z's. Let's just draw a picture. If we mark -1 here, when I plug in a -1 into z plus 1, we're going to get 0. Okay, so it makes sense for all z's not part of this branch cut. So it makes sense all of there. And here, to differentiate, what do we do? Well, this is a linear function of z. So when we apply the chain rule to differentiate the inside, we just get 1 because this is a, if you like, this is a translation. So the rate of change doesn't change under a translation. So what we're going to get here is 1 over z plus 1. Or you can do the chain rule if you like. But I prefer to think about this as like, oh, does translating affect the slope? And the answer is, of course, no, it doesn't.